Welcome everyone to a quick overview of lesson 2.2 from calculus, which is all about defining what a derivative is. So for this first part of calculus, after you get done with limits, you start to do something called differential calculus. And differential calculus is all about finding and taking derivatives. So today we're going to define what a derivative is, and I've kind of got us started. A derivative is another name for an instantaneous or an instant rate of change, how something is changing in that moment. So there are two different notations that mathematicians use. They're kind of useful in different situations. The first one is f prime notation. So this f prime of x, or equivalently, you could use this dy dx notation. They both have their different uses. You'll see this one used a lot more when we're not dealing with a context, and this one used a little bit more when we are, but other than that, they are equivalent. And what is instant rate of change? Well, we talked about that a little bit last lesson. The instant rate of change is the limit as h approaches 0 of f of x plus h minus f of x all over h. And you might be like, that looks a little different. We had a's last time and you put x's here. Well, the difference between 2.1 and 2.2 really is that we are finding the instant rate of change defined for all x's of a function. So the cool thing about finding the derivatives of functions is that their derivatives, or instant rates of change at any given x value, is also defined as a function. So our goal is going to be to find them using this limit here. So we could pick an x value, we could pick any a value we wanted and substitute it in, we could find it doing the long method, or we can do the long method once and then use the result of that to find the derivative at any given a value. So let's hop into an example. Here's an example for us, and in fact it's the same example we used in the last video, this x squared minus 1. And in this case, I'm wanting to find the value of the derivative at 3 different places. It doesn't make sense for me to go through and do the long method for every single one of them. So let's find f prime of x first. And then we can substitute these values in and figure out what they are. So f prime of x is the limit as h approaches 0 of f of x plus h, so that would be x plus h squared minus 1, and then we're going to subtract just this f of x, so this x squared minus 1. We're going to put that all over h. So we can clean this up a little bit to start. First, we can change the signs of everything over here, and then we can clearly see that these ones are going to cancel. Then we can double distribute this, and that will end up being, it'll be x squared plus 2xh plus h squared, and then we have this minus x squared over here. And that's all over h. We can see some other things cancel out. We have a positive x squared and a subtract x squared, so those would cancel, leaving us with two terms that both have h in the numerator and then just a sole h in the denominator. We can go ahead and cancel an h out of each of those terms, and that should leave us with the limit as h approaches 0 of 2x plus h, and if we evaluate this limit now as h approaches 0, we get 2x. So we get f prime of x is equal to 2x. So what does that mean? That means the instantaneous rate of change of this function up here, defined for any x value, is 2 times whatever the x value is. So in this case here, this f prime of 1 would be equal to 2. So the instantaneous rate of change at 1 would be 2, at 2 would be 4, and at -2 that would be -4. Why do we find derivatives? Well, you're going to get asked a lot in calculus to find the equation of a tangent line. We talked about tangent lines before, right? Tangent line, its slope is the instantaneous rate of change. That's how it only touches the function once at that given spot. So your tangent line, write that down here, your tangent line is defined as y minus f of a equals f prime of a times x minus a. And a could be any x value we want. We take the a value, we subtract it from the x here, we plug it into the original function, and that gives us the y value of the point, so we use that there, and then we plug it into the derivative, and we can find the slope. And that is what derivatives are. Defining derivatives. They're the equations of not the equations of the tangent line. They are the slopes of the tangent line. They are the instantaneous rates of change, and we're going to be doing a lot with them through the next few units. Good luck on your practice, and I will see you in the next video.